Hello. Today we are going to be looking at section 24 in the book. It's talking about the number line and how we can use the number line to provide a picture to sort of explain what's going on as we teach students things about addition, subtraction, multiplication, and division. So it's something to fall back on if you want to be able to provide some sort of geometric pictorial representation of the mathematics at hand. So the first thing we're going to do is discuss addition. And addition is something we've explored in this class before, and we used bases to sort of explain why we carry and how certain things work, and so we've kind of explained it and explored it algebraically a lot, but maybe it would be nice to be able to draw a picture associated to it. So we're going to go ahead and start at 0, and we're not going to worry about negatives for this part because we want to explain this to a student. If they're trying to study addition, we're not going to try to go and make it more complicated by having negatives involved. We want maybe to be able to talk about them as natural numbers. I'm only going to put natural numbers and 0 on this number line. Maybe I can squeeze 8 in there also, so as not to confuse them. So let's say I wanted to explore the problem 2 plus 5 for a student that just wasn't getting it, how to add, and maybe using your fingers doesn't make a lot of sense. So what you could rely on now is a picture. So maybe they understand, if I have 0, then I have 1, then I have 2, this is going at a steady pace, and here are all the numbers that I've learned about thus far. Now you can say, okay, well if I start at 2, and I'm going to make 5 jumps, I'm going to gain 5 things, whatever they may be, it would look like this. 1, 2, 3, 4, 5. And you would land there. So now you can conclude that 2 plus 5 is 7. And it can also work similarly with subtraction. So I'll change this to subtraction. Let's say I wanted to do, I was thinking of doing 6 take away 3, but I don't like having the number appear twice, right? As the thing that's being subtracted and as the result, the difference. So let's try something else. Maybe we could do 8 take away 3 and see where that lands. So I have 0, let's say however many things I have, apples or whatever else. I made it all the way out to 8. 6, 7, I have 8 things, and now I'm going to head back towards 0 because I'm losing things, and I'm going to do it 1, 2, 3 times. Fairly straightforward, right? Hopefully it's something we've seen before. So that's how you could sort of incorporate the number line model to explain subtraction. And now maybe multiplication. A lot of the pictorial models for multiplication, if let's say I want to do 3 times 5, I might recommend saying, okay, you have 3 groups here, each containing 5. How many is their total? And it's the same amount as if I had 5 groups, each containing 3. And they can total that up for themselves and sort of see what's going on. But if this wasn't working so well and you wanted to have some other sort of tool to use, you could also bring back the number line. So again, I'm going to start at 0, and then I'm going to number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, oh, I need to extend this a bit, 12, 13, 14, 15, which is enough, but I'll just make 16 also, and then the arrow to show that it keeps going forever. We can keep making this number line farther and farther. Okay, now you can say that I have 3 jumps, each 5. So I have 3 groups in multiplication. The word for multiplication is of. So I have 3 groups of 5, and that's going to look like this. So I have a group of 5, and then I have another group of 5, so 1, 2, 3, 4, 5, that lands me at 10. And then I have one more group of 5, 1, 2, 3, 4, 5, and that's going to land me at 15. Now I can see 1, 2, 3 groups of 5 each, and then they can sort of see that. And I can also go the other way, so I'll do that in a different color. What if I wanted to remind them that this is the same as 5 times 3? So I could say I have 5 groups of 3. So I'll go, okay, 1, 2, 3. My first jump of length 3, 1, 2, 3. Second jump of length 3, 1, 2, 3. Third jump of length 3, 1, 2, 3. Fourth jump. And then 1, 2, 3, and there's my 5th jump of length 3. Now I can see the 5 humps that are pink, and they're each of 3, so I can see that 5 groups of 3 is the same as 3 groups of 5, and I've displayed this on a number line. Now let's talk about, lastly, division. And I'll mention this now, because it's in the middle of the video. I hope you watch all of it. That this will not be having a discussion post on Alima, but it is fair game for any exam. And please continue watching to see how division works. Okay, so let's say zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say with 12, I wanted to know how many groups of 4 were in 12. The way the book explains that you could do this is saying, okay, let's see. Well, if I had 1 group of 4, 1 so far, that's not 12 yet. What happens when I consider 2 groups of 4? I get over here to 8, not yet. And 3 groups of 4, and bam, I made it. So evidently, 12 divided by 4 is 3, because I have allocated 3 groups, 3 jumps to get all the way to 12 if I was jumping 4 at a time. So just keep in mind that the number line is a good way to explain not just how numbers are arranged and how to order them, but also how to operate within them. So how to add, subtract, multiply, and divide. Okay, thank you.